questions before we start today? All right. Number between 3 and 6.
6.
1, 2, 3, 4, 5, 6.
One.
What's your name? Chase. What is GDP? One, 2, 3, 4, 5, 6. What is GDP, Chris?
Dollar value of all final good and service produced within a nation's boundaries over some time period.
Good. Chase, what is GDP?
Dollar value of something.
Chris, what is GDP?
Dollar value of final goods and services produced within a nation's boundaries over some time period.
Good. Chase, what is GDP?
Dollar value of final goods and services based on something.
Chris, what is GDP?
Dollar value of all final goods and services produced within a nation's boundaries over some time period.
Chase, what is GDP?
Dollar value of all final goods and services produced within a nation's boundaries over some time period.
Great job. Nice work. It is important for all of you to have that off the tip of your tongue. It's one of our primary things we're going to be looking at this semester as a measure of social welfare. In some cases, it sucks at measuring social welfare, but on many times it does a pretty darn good job of indicating social welfare. So today, I want to start you off with the ups and downs of the economy. How many people have heard that in the news? The economy's up, it's down, it's fluctuating, it's moving all over the place. Well, that language of the ups and downs, recession and expansion, things are good, things are bad, that is all tied into what we call the business cycle. So I want to start you off today with the business cycle. And what the business cycle does for us is it maps out GDP over time. So on the horizontal axis, we're simply measuring time. So imagine we're in 2010, 2011, 2012, 1964, whatever it is. And on the vertical axis, we're measuring gross domestic product. So we learned something last time that we can look at the dollar value of all final goods and services sold, and what is that equal to in the grand scheme of things? What is that also equal to? Why is that kind of important to think about the dollar value of all final goods and services sold? Wages and income. So this is an important one to have conceptually. The dollar value of all final goods and services, all the crap we buy over the course of the year, that goes on in what we call the output market, the market for final goods and services. You making your trips to Walmart, buying the stuff that you need. But there's another market, the resource market. All of the resources are owned by households, and they sell them to businesses, and in return get income. So last time we did the income approach to measuring GDP and the expenditure approach to measuring GDP, because the dollar value of all final goods and services sold up here is equal to the income that's earned by people on our island over the course of the year. So start to be thinking about GDP as income as well as spending. The two are interchangeable. So GDP, you might put in parentheses here. This is the income of the nation. All of our incomes added up. When we map that out, that's the ups and downs. And so it goes up, goes down, just kind of trace it through over time, and you get some sort of squiggly line with ups and downs, depending on how we map it out precisely. So economic growth, if you hear the news media throwing out the economy grew by 0.5%, the economy grew by 2%, the economy slowed down by some amount, they are talking about this variable GDP. And so over time, we hope that on average, GDP is growing. So if we think about kind of the long-term growth, it's really an average over time. We might refer to this as a trend line. The trend line. We hope that that has an upward slope to it over a longer period of time. One of the reasons we hope that it has an upward slope is that what type of slope does population have? Upward slope. So the population's growing, so even to maintain our level of welfare per person, income per person, we need GDP to be growing as well to maintain income per person on average. So we also look at what's called per capita income. Okay, so one key point here, a couple key notes. Upward sloping trend line means the economy is experiencing long-term growth on average over time. We're going to spend a whole chapter, chapter 6, on long-term growth and start thinking about why does economies, some have maybe an upward slope, some might be downward slope or flat. So we'll be looking at that in a different chapter. So I just kind of want to foreshadow that now about that average long-term growth. I'd also like you to put a second note about the population. So since the U.S. population, I heard an interesting statistic the other day that I had not heard before, so I'm not sure if it's true, but I haven't had time to check it, that the U.S. is the only industrialized country that is experiencing population growth. So if you take Germany and Great Britain, their population apparently, according to this source, which I don't even know the source, I think I heard it on NPR, is fairly flat. Conceptually, I could kind of see that. I mean, Japan is busting at the seams. I mean, how much more people can we have? You know, you might be losing people. They might be going other places. I'm not sure. But I do know that the U.S. has increased population growth. So since the U.S. Population is growing, we want GDP to grow in order to maintain per person income. Per person income, which we refer to as per capita GDP. Per person GDP, or income per person. So another little side note to keep in mind as we think about this. So the long-term growth is one thing to look at, but short-term changes, and when I say short-term, it might seem like an eternity to you, but over the course of a year or over the course of a couple of years, you know, what's going on in the economy tells a story as well. So as we track GDP, we've got 4 parts, sometimes referred to as just 4 phases of the business cycle. So the cycle is the ups and downs, which gives us then these 4 parts. So this is a part, let's just call it part A. It's a turning point, right? We stop going down, we start going up. It's a turning point. So part A is a lower turning point. And it's also called the trough. So we think of a trough, maybe that some pigs are eating out of or some cattle. It's the bottom part, the trough. The second part then is this increasing area up to the higher turning point. So we've got the higher turning point. Now, if you guys had the liberty to name this and title that point, the turning point, what would you call it? Peak. Good. We usually have a few people think about peak, right? So we got kind of a mountain going on. We got the peak of the mountain. So that is the peak. And this phase in between we call an expansion, the expansionary phase. A period of expansion. GDP is going up. So if we map 2 points out here, A and B, GDP over this time period has gone up. It's expanding. The economy's growing. And then you guys probably know this phase. What is that called here? Moving towards another trough? Recession. So that's our recession. So, recession. Okay, so those are sometimes referred to as the 4 phases of the business cycle. 4 phases of the business cycle. Okay, couple little, I guess I might as well just add on note 3 here. There's a few different things that have evolved over time on what a recession is and what it's not. And so the technical definition for a recession is a 2-quarter decline in GDP, a 2-quarter decline. So how long is that? 2 quarters? Half a year, 6 months. So 6 months of falling GDP. So if the economy slumps this month, according to some economists' predictions, it's not necessarily a recession. A recession is when we've had this kind of sustained period, which was arbitrarily picked to be 6 months, at least 6 months worth of falling GDP. So technical definition of recession is a 2-quarter decline in GDP. Same thing with an expansion. We need to have a couple quarters of expansion. Same 2-quarter for expansion. Because the statistics on this could look like this if I embellish a little bit on my graph here. So as we were going up, we actually came down a month, but then we went up by a couple more months. And so if we put in a lot of detail, there might be little ups and downs along this, right? So it has to be this kind of sustained movement of one dwarfing the other for us to call it recession or expansion. So note number 4 is that there's a looser definition. A looser definition of recession. Now, I'll start you off with my real loose definition would be things just kind of suck. And what are some sucky things that go on you've heard during this recession? Unemployment, good. High gas prices, so high prices. So there's some other variables that are important besides purely just GDP. That's one of the things we're struggling with this recovery that we're in now. So the economy is expanding, but it's expanding on a really flat line. And unemployment is still fairly high relative to where we expect it to be long term. So despite it being good times according to GDP, things aren't so good. And so there's been alternative definitions that take those sorts of things into account. So I'm just going to add some bullets on top of the things suck, like higher unemployment, possibly inflation, which is, we haven't got to defining that yet, but rising prices, like you said, high gas prices maybe would be something. So there's other variables that we could look at to say that things aren't so good. But we need to know the tight definition of what we're dealing with, and then we kind of looked at other issues. All right. So I think that hits. Okay, that wraps up basically chapter 4 material. 4 and 5 kind of go together. We're going to look at an issue that we have with GDP that's a bit of a takeoff from one of the ways I presented GDP to you earlier. So I guess let's go ahead and call this chapter 5. So most of this is bringing in unemployment and inflation. Since I just kind of brought those up, that's where chapter 5 takes us, is into those other important variables. So recall our math goggles for GDP. So definition-wise, it was the dollar value of all final goods and services produced within the nation's boundaries over the course of a year. Equation goggles would say GDP is equal to the sum of all prices of N goods out there. I eventually brought this, in your notes you should have this all written out, so I'm not going to spend time doing it again, but I want to refresh your mind verbally. Price of haircuts, quantity of haircuts, plus price of lawyer services times the quantity of lawyer services, right? So we have a bunch of spending that's going on a whole bunch of stuff. And that's what gross domestic product is. Now, connect the dots for me over here. How does GDP go up? So how can GDP increase? More spending. Okay, let's be even a little more specific using this formula. So definitely more spending, more dollars being spent. How? Thinking about the composition of GDP. Good. So price or quantity, right? So if we really dissect this and think about it maybe more mathematically, if any one price, Jocelyn brought up gas prices. So if gas prices go up from $3 to $3.30, and that's the only thing that happens in the economy, did GDP go up? Yes. I'm holding gas constant, saying that, which is not a good argument, by the way, but given just using the math here, people buy the exact same amount of gas, prices went up from $3 to $3.30. I'm glad we picked gas, because that's one of those things where people do tend to kind of behave that way. It's fairly, they're fairly unresponsive to price changes. So if this goes up and this doesn't, GDP goes up. So let's write that down. How can GDP increase? We can have an increase in price and quantity constant. How else can it happen? Increase in quantity, price is constant. So for some reason, people are buying more at fixed prices. So we can have price constant and quantity increasing. And then finally, we got one more choice to get this to go up. They both go up. I guess we have 4 choices. Sorry, that was not the one I was thinking of. Okay, so an increase in price and an increase in quantity. And then we got case number 4. And maybe there's actually case 5, but we could change this into 4 or 5. So both going up. How else could we get GDP to go up? One goes up more than the other goes down. Yeah, right? So possibly prices could be falling a little bit, but people are doing more. Or prices are going way up and quantity's falling a little bit, but the price effect is bigger than the quantity effect. So some sort of mixed effect. So my case 4, I guess I'll keep it simple. The up of one outweighs the down of the other. The up of one outweighs the down of the other. All right, well, conceptually, that's important. As we tie this back to welfare or well-being of society. Katie?
If the population increased, like if we had people moving into the country or like the baby boom, would that also increase GDP?
We would need one of these, since we're measuring GDP this way, there's nothing to say about population. So you're bringing in kind of another variable that's not being accounted for here. So these are truly the only ways we could get GDP to go up. Your thing with other things changing could make it happen. But as far as sticking to our P's and Q's, this is it.
Your population is
Yes. All right, so thinking back to the big picture on social welfare, what really, truly brings you benefit of some sort? Is it the P or the Q or both? The P or the Q or both? So give me something that makes you happy. Anybody? Decreased prices, okay? Makes Katie happy. What else? Chocolate makes Brianne happy. Now, if I give Brianne more chocolate, her happiness goes up. If I give Katie lower prices, but no way to acquire more goods, does that make you happier? And you can't spend it in future time periods because I'm looking at a snapshot in time. Does a price change make you happier? No, you think it does because that's the way we're all conditioned. But it's the things that money buys that brings you pleasure, not the actual price of the good itself. If you dig down deep, do some soul searching, it's the things that you're getting. The things that money buys you is what brings you happiness, not your income too, by the way. So if I said, hey, would $10,000 bring you some pleasure, some extra income of $10,000? Now you're talking to an economist, so you got to be careful. The first thing you should say, well, wait a second, what are you holding constant? All right? Because if I give you $10,000, but I'm holding constant your ability to use that for anything else than you would a big pile of paper, a big $10,000 of $100 bills, the only way that's going to bring you some pleasure is if the world's ending and your hands are cold and you can somehow light a match to it to bring you some happiness, some benefit from that paper. Because if there's no way to use the money to get the things you want, it is meaningless. So this is important as we start to look here, because are we happier as a society? Is society better off under this first bullet point? No. There's no more people being fed. There's no more diapers for babies. There's no more anything. We've got the quantity of stuff being constant. We just have higher prices. So what we really want for prosperity is more Q. We want more stuff. So we've got kind of a problem with our measurement of social welfare, in that there's a combination of price and quantity here, one of which gives us value, the other one doesn't give us any value. So we want to be able to focus in on the Q rather than the P. So we've got a solution for that. We're going to run through a little exercise of calculating GDP with some real numbers. So if this stuff is just kind of floating around in your brain right now, hold on tight. We'll try to put some numbers to work to help us. Okay. Suppose we've got the year over here. And we've got, 20, let's go just 2001, 2002. We're going to have scheduled numbers of 6 years. 2004, 2005, 2006. We're going to have about 1, 2, 3, 4, 5, 6, 7, 8, about 8 or so columns. So leave yourself enough room to the left-hand side of your paper, and remember we're going to end up going this way with about 8 or 9 columns. So we have the price of good 1. We're going to just say that there's 2 goods in our economy. 2 types of goods. Good 1, and then we're going to have good 2. And so in 2001, the price of good 1 was $7, and the quantity was 25. In year 2, the price went up to 9, and the quantity fell to 20. In year 3, we went up to 11, and quantity went up to 30. In 2004, the price stayed at 11, quantity went up to 35. 13 for 2005, we're at 32, and 13. We stayed the same. We stayed flat with good 1. Our next columns are going to have the prices and quantities of good 2. And so let's say our price of good 2 was $8, and we had 20 units. Went up to 9, we had 25. Stayed at 9, dropped to 20, went up to 10, 20, 11, 25, and 13, and 32. Okay, we've got enough information then. If we have a simple economy, calculate GDP for each year. So pull out your calculators if you got them. Work with your neighbor if you're a bit confused. We're following this formula. Now that n equals 2, all we're doing is P1 times Q1 plus P2 times Q2. And you guys calculate 2001, 2002, 2003, 2004, 2005, 2006, and 2001. You guys will double check their work. Okay? As soon as somebody in your row, 2001, 2, 3, 4, 5, 6, and you guys are 1, as soon as you get an answer, Shout it out. First person with the answer, whether it's right or wrong, gets an extra credit point.
7.
Okay, so I heard a 7 from Julian first. He's got an extra point on the board. The next point goes to the people with the correct answer. Go. 1, 2. Oh, geez. I need hands in the air, I think. Oh, jeez. How much? 335 for 1. All right, hold on. I got to get my pen out here. Start dishing out some action. All right, so Jesse, 335, if you're right. Who's my 2? Michael.
405.
405. So let me just put a little M here for Michael. 405. Rachel. 510. I think I saw Rianne first. 585. Ugh. Austin. 691. Riley. 832. All right, so let's see. I usually throw out new numbers, but I actually used the numbers that I did this time. That looks fine with what I had. Okay. So the problem is there was some mixes and matches of things going on here, right? Some P's went up, some Q's went down. What's true about GDP over this time frame? Increasing, 335, 405, 510, 691, 832. Increases all across the board. All right, but we've got this mix of other things going on, potentially with the prices. So how could we possibly come up with a new measure of real GDP so that we get rid of that price effect? So what I'm thinking about here is a new way of thinking about this. We've got price times quantity in each year. How could we devise a little plan to filter out that price effect and only capture the quantity effect? What's that? What?
Like a price level.
Okay, well, give me details here using these numbers.
Like off of the base year, so you can use the price from one year to the other quantity.
So pick a year and use those prices. Okay, that's one way. Other ways. We could think of a few, I think. No, we don't have anything on the benefit side. Michael?
Make all the times 1.
Okay. Now, we might have some problems if we fix them all to being 1. We'd have the quantities, but then we're kind of adding apples and oranges. And so let me just say what that would be equivalent to. If this was apples and this was oranges, then GDP would become 30 plus 20 is 50, right? 35 plus 20 is 55. Is that fair to add apples and oranges and saying that whatever the quantities go up? Do we add apples and oranges back from it? No, that's not really fair. So the dollars help preserve value to some degree, which is a little bit maybe what Katie was talking about. The fact that this one's higher priced than this one gives us a little information about the value of that apple or orange to society. So I don't want to just change them to 1, but you're onto something that might work. Michael, you want to amend your proposal?
Well, I was going to say, so like, make the 7 and 1, see how many you get for each dollar, so you take 25 divided by 7. But I don't think.
Nope. Yep, that approach wouldn't do it. Let me come over here.
Take an average price.
Take an average would work. Yep. An average would work too. The mean, yes. You could take the mean. You might be able to get away with it. Anyway, our goal here is to fix something here. If we fix the prices some way other than changing them all to 1s, then that would be another technique we could do. All right. So all of those would be possibilities, and And in fact, the averaging technique is a little bit the more sophisticated way that it's done. But we're going to take the simplified way of picking a base year, an arbitrary year, to center those around. So since Chelsea came up with the base year, I want to show how this works. I had, this is like the magician's trick. Chelsea, have we talked before class today to set anything up? Okay, no, we had to make that. Okay, so you are free to pick any of these years. Go ahead and tell me what you want to be the Chelsea base year. 2003. Okay, so we are going to pick 2003 to be the base year. So our next column to do is what we're going to call real GDP. And we're going to use the Chelsea base year prices to recalculate numbers in the same way. So our formula for this, using these prices the way we've got them, is the prices in the base year times the quantity in year I, whatever year we're looking at, plus the price of good 2 from the base year times the quantity of whatever year we're looking at. So I might not have, how I'd rate this with the 1 and the n is we'd take, we've got apples and oranges. More generically, we're going to pick the base year, which is 03, because Chelsea picked it. And we're going to calculate the real GDP for, let's say, 2002. I'm just picking out one. We're going to use the 02 quantity and the 03 price. Recalculate all the numbers.
Does it matter what year you pick for your base year?
It does not matter. Yep. But I didn't know which one she was going to pick. And we'll come back to that point later, that it doesn't matter what year we pick and why. So calculate real GDP. Soon as you're in your rows, 1, 2, 3, 4, 5, 6, tell me what numbers you get. Just say I'm at 4 and I got this amount or whatever. There should be an easy one. I'm not hearing 510, 2003. Yes, that's the one we want quicker. What else? 445. What else?
2006, 640.
640. I don't have these worked out ahead of time, so 04, 565. Okay. 2 left. How's our ones doing over there?
I got
455. Yeah, and if you're wrong, you're wrong. We'll just double check with what your other people in your row got. No big deal. 2005. Cole, what do you got? 627. Everybody else in row 5, if you're in that same row, double check our work. I do not have these worked out ahead of time. Okay. 577 for 2005?
Yeah.
How many people got 577? Raise your hand. 1, 2, 3, 4. Okay, so 577. 577. How about these other numbers? I do not know the right answers. I haven't calculated this one. We're good? Confirmed? Okay. You can see that the picture we get is different now, right? Now that we fixed prices, we filtered that out. 455, there's actually a drop in real GDP here. Then we go up, 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 and up. But the amount of the ups is the next thing we're going to look at. What is the amount of the ups and the amount of the price ups? So we can get some more information here by thinking about the percentage changes. So economic growth is the percentage change in real GDP. So here's our interpretation of this shorthand. Percentage change is the triangle. So that's a little shorthand math notation using a little triangle for change. I'll use that a lot this semester. So this is the percentage change in real GDP. And I'll put the word real here and then use our GDP since we've defined that earlier. Well, it's a delta, but yeah, however you want to draw it. Okay. How the heck do we do that? Percentage change. Where's my math people? Okay, subtract it. You're partway there. So if we look at the change is 577 minus 565 gives you the change. But how do we convert it to a percentage change? You're partway there. And what? Nope, one more step on top of that. The 100 part is part of it too. So now you're not halfway there. You're probably point with that part. You're 0.6 of the way there now. Okay, what else? Divide by the original. So new number minus the old number divided by the old number. So this is your kind of old way of doing some of your math problems from class. The percentage change in some variable x is equal to the new number. Now you might have used x1 and x0, right? So I like to just think of new number and the old number here when we're dealing with time series data like this. So the new number minus the old number divided by the old number. And now, I'm sorry, give me your name again.
Shelby.
Shelby, what's the thing that's missing from here? I'll give you a hint, you just said it. Times 100, yes. Technically, you got to slide that over. The times 100 business is just to convert it to a percentage. So highlight that for yourself here. This is our little trick that converts it to a percent. Now we'll find that out as soon as we do one of these problems. So let's do one. What is economic growth for 2005? So example, what is economic growth for 2005? We're using all real GDP, and I'm looking for economic growth for the year 2005.
So would the old be 2004?
Yes.
Okay. So it's 2.12%.
2.12%. How'd you get that?
577 minus 565 divided by
Okay. Times 100. So I want to stop there to make sure this is, sometimes when you go back and forth on these problems, this is where you can lose some points on a problem. So I know this might sound very trivial to some of you, but I want to highlight it for even you brainiacs out there because you might screw this one up too. So this number, what fraction do we get here? 0.2. Okay, and 165 I heard too. Did I hear, or was it, is it 0.20 or did you do some rounding here? 0.02. 0.0212. So then the multiply by 100 business, all we're doing is shifting this decimal place 1, 2, so that that decimal now becomes equal to 2.12. Wrong answer on a test. This is a right answer. This is a wrong answer. I don't care which one you do, but make sure you do it right. So 0.0212 is an answer that is correct. But 2.12 has to have this symbol after it to make sense. Because then we can go back and forth between the two. Those two things, those two expressions are equivalent to each other. So the economy grew by 2.2%. What was growth for 2005 here? Using the old GDP that we did. How much? 18%? 18.12 if you guys whip that one out. So you can see that that would tell you that the economy grew by a lot. Oh, these are awesome times. I don't know when the bubble's going to burst, but the economy is growing crazy. Well, most of that growth was price growth, right? If we kind of dive back over here, we jumped from 11 to 13 and 10 to 11, so there was a lot of price growth, but that didn't help us out that much. So we've got a new way we're going to characterize this GDP. This is now nominal GDP. So the way we were doing it before was called nominal GDP. I just didn't tell you that because we hadn't gotten to what real GDP is. So, nominal GDP is the value of the final goods and services in current year terms. In current year terms. Real GDP is the value in base year terms. And by doing that, we've sucked out that price effect. We've held that price constant, and we've kind of sucked out the price effect. So we'll put that as the last bullet here. It removes the price effect. We're going to add on to this by showing how we can separate that price effect from the quantity effect. The price effect, those percentage changes, is inflation. So that's where we're tying this back to. This is exactly how we calculate inflation, is by separating out the price effect and the quantity effect. We'll pick up there on Monday. Yes. You guys get Friday off.